Hi, my dear Uncle Dummy. Here I am. How are you? Soil, plant, and water relationships is our second subject. The real philosophy of irrigation practice is to ensure that the plant has supply by an adequate quantity of water in each root distribution zone for obtaining an optimum growth and good yield. We will divide this subject to two parts. Part A, soil composition and management. Soil is a natural mass of minerals and organic particles arranged in a special structure containing water and gases which effect on the growth of plants. Please look to the attached figure and see by yourself. Plants requiring a little quantity of water for both its metabolism and nutrient transpiration processes, while requiring large quantities for its physiological process of evapotranspiration, which acting as protection from the harmful effect of climate conditions. Soil management is the application of operations, tactics, and treatments to protect soil and enhancing its performance such as soil fertility, quality, and physical properties. While soil health is the state of soil meeting its range of ecosystem functions as it's appropriate to its environmental. Soil quality is a measure of the soil condition relative to the requirements of one or more species and or to any human activity or purpose. Soil resistance refers to the ability of soil to resist or recover its healthy state in response to disability influence, while soil biodiversity refers to its biodiversity and manifests in relation to the biology activity. Soil fertility refers to the ability of soil to sustain agricultural plant growth, in evidence to provide plant habitat and result in sustained and consistent of high quality yield. Soil buffering capacity represents its ability to release up buffered agents to keep its pH value without any significant change. Soil contamination is a part of land degradation caused by the presence of some hazard poison materials in soil, which causing a change and alteration in the natural soil environment, while soil porosity describes the procedures which can be done to prevent soil degradation, less productivity, and pollution caused by non-correct farming practices. Soil texture refers to the relative of particle size distribution, which ranging from clay particles of less than 0.002 mm to stones of up to 20.0 mm diameters. Soil texture triangle, look by yourself. It consists of 12 textures. Table of classification of coarse fragments. Please note that the size and textural name depend upon shape and the kind of fragment. Table of classification of effective soil particle fraction, USDA classification. Please look to the fraction name and its effective particle diameter by both millimeter and micron. Table of some physical properties of different soil textures such as infiltration rate, porosity, bulk density, field capacity, permanent wilt point, and available water. Soil structure represents the arrangement of individual particles and aggregates with each other in a soil mass uses certain semantic properties. Figure on different types of soil structure such as granular, angular blocky, subangular blocky, platy, columnar, prismatic. My dear, look by yourself and note the differences between each other. Look, my dear, the describe of each structure and its definition for granular, prismatic, column, and also for blocky and platy structure. Look by yourself, my dear. Grade of structure is the degree of application, expressing the differential between cohesion within aggregates and adhesion between aggregates. Four major grades rated from 0 up to 3 as follows. Grade 0, structuralist. Grade 1, weak structure. Grade 2, moderate structure. And grade 3, strong structure. Table showing the soil classes of structure depend upon its unit size by centimeter. Soil porosity or soil pore spaces are the smaller open spaces or voids in between soil particles. Total porosity equals the ratio between the volumes of void space to the total soil part volume. There are three categories of pores in soil, such as macropores refer to pores greater than 60 micron diameter. Mesopores refer to pores greater than 20 microns and less than 60 microns diameter, while micropores refer to pores smaller than 20 microns in diameter. Anyhow, total porosity can be calculated from the bulk density, saturating fluid density, and mean particle real density. Soil Science Society of America, SSSA, adopts different terminologies concerning the movement and flow of water through soil, such as hydraulic head, hydraulic gradient, hydraulic conductivity, permeability, flow velocity. My dear, look by yourself and know the differences as written. Hydraulic head in saturated soil can be determined in the field by installing piezometers at different depths in the area. Table, look by yourself, shows the soil hydraulic conductivity values approximately under different soil texture. Flow of water in soil refers for acting different gradient variables such as metric potential, osmotic potential, gravity potential, thermal potential, and hydrostatic potential. Scientists Darcy studied and described the flow of water through soil. He concluded that the rate of flow is reversely proportional with length of soil column, while directly proportional with both the hydrostatic potential differentiation and the cross-section of soil column is known as Darcy law. Table on soil hydraulic conductivity and its values under different classes and dimensions. Look by yourself, my dear. Determination of soil hydraulic conductivity can be done easy in the lab by obtaining an undisturbed soil sample by using a metal cylinder and measuring the collection volume of water which penetrating from this sample in a definite time. There are two methods for determination the hydraulic conductivity directly in the field, which are known as auger hole and the piezometer method. Auger hole method. My dear, please follow the procedures exactly as you see by yourself and apply the remembered equation. Look to the perimeter Take in consideration that the average value of hydraulic conductivity by auger hole method represents the horizontal conductivity of soil layers below water table in unlined cavity. Bathymeter method is based on measurement of flow at the lower end of lined hole with leaving a cavity space of 10 cm under the bathymeter bottom. Look and apply the equation and its parameter. Figure on determination of hydraulic conductivity by both auger hole and bathymeter method. Permeability is the absolute ability of soil to allow fluid to pass through it, which is ideally property of medium fluids alone, without interaction with fluid characteristics. Tables of permeability rates for different soil textures and structure types. Permeability is usually expressed either as permeability rate or as a coefficient of permeability, as illustrated in the attached table. Determination of soil permeability rates and coefficient is clear in front of you, my dear, followed by yourself. Figure on determination of permeability coefficient. Look to the enclosed parameters and apply the equation. Soil infiltration is the process of entering water into the soil surface at a given time, which is known as infiltration rate. Entering water into the soil surface starts rapidly at the beginning and decreasing with time gradually, and tends to approach a constant value after a time, as clear in the enclosed figure. There are many infiltration terminologies, such as instantaneous infiltration rate, cumulative infiltration rate, average infiltration rate, basic infiltration rate. Look and follow by yourself, my dear. Infiltration capacity is the maximum rate at which a given soil under field conditions can absorb water. It can be determined by 4 methods, such as cylinder infiltrometers, watershed hydrograph, rainfall simulators, and basin method. Table of classification infiltration rates as influenced by soil texture and structure. Really, it is very important to determine the soil infiltration rate practically in the field as the main factor in designing an irrigation method. As example, in designing furrow irrigation method, there are 2 methods such as buffering method and furrow infiltrometer. Double ring infiltrometer is a suitable common apparatus which can be used successfully in designing border strips and basin irrigation methods. The mechanism of infiltration under sprinkler methods clearly differ than gravity irrigation methods, as there is an impact forces by water drops falling on the soil surface, and so the best way is to use the sprinkler itself as infiltrometer. On the other hand, in designing micro irrigation methods, for obtaining the optimum infiltration pattern practically in the field, as this case can be carried out by some procedures which you can follow it by yourself, my dear. It is obvious that containing excessive concentration of soluble salts in soils considered a severe problem which requires special management practice. Soluble salts produce harmful effects to plants by increasing the salt content of soil solution and also the degree of saturation exchangeable of sodium elements. Chlorine, sulfur, sodium, calcium, magnesium gradually released and is soluble during the chemical weathering. On the other hand, bicarbonate ions form as a result of solutions of carbon dioxide in water and is an active chemical weathering agent that releases appreciable quantities of carbonate. Also, carbonate and bicarbonate ions are interrelated relative amounts of each percentage, being a function of the pH value of soil solution. Saline soil definition, which is conductivity of saturated soil paste, is more than 4 decimels per meter at 25 centigrade. The United States Salinity Laboratory classified saline soil at this point of view for 4 classes: non-saline from 0 up to 4.5 decimels per meter, slightly saline from 4.5 up to 9, medium saline from 9 up to 18, and highly saline more than 18 decimels per meter. Table on classification of salts affected soils, electric conductivity of soil base, soil pH, changeable sodium percent, physical conditions for slightly saline, saline, sodic, and saline sodic soils. Salt balance. It is a difference between input and output salt components in soil by different resources. Hence, overall salt balance of irrigation zone, and salt balance to groundwater should be taken into consideration as clear in the equation in front of you, my dear. My dear, follow the important parameters of salt balance equation in front of you. Accordingly, there are 3 types of salt balance, such as transition type, which is meaning neither accumulation nor leaching has occurred; positive salt balance, which is meaning salinization; and negative salt balance, which is meaning desalinization. Moreover, suppose elaborated an equation for the practical determination of salt balance in soil under irrigation conditions. Follow it, my dear, and note that this equation can be used to determine the ionic balance in the different soil layers.